Michio Kaku has just released a striking new analysis. He argues Earth is moving through an interstellar debris stream dense enough to triple our hit rate from other star systems. The evidence is real, the data is measurable, the implications are immediate. Think about what that means. We're not just witnessing random visitors from deep space anymore. We're inside something. A cosmic highway of debris. A concentrated band of ice and rock that shouldn't exist where we are right now. Kaku's claim centres on a sharp jump in detections. 3 interstellar objects in 7 years instead of the expected one every 10 to 20. These aren't small variations. These are massive statistical outliers that demand explanation. His calculations show this pattern is too steep to be random. The numbers point to a temporary stream, a narrow lane of roaming material that cuts across our orbit. Not permanent, not stable, but dense enough to flood our detectors with objects that shouldn't be here. And the latest visitor proves it. 3i Atlas is shedding the weight of a small car every second, not when it's close to the Sunday, not when it's hot, but right now, far out in space where comets should be quiet. Think about that for a second. Every single second, this object loses 40 kilograms of material. That's 88 pounds vaporizing into space. At distances where normal comets barely show activity at all, the carbon dioxide output makes even less sense. 8 times higher than normal. Not double, not triple. 8 times the expected ratio compared to water. That level defies what solar system comets do. It challenges every model we have for how these objects form. Kaku points to this as proof of exotic material, stuff that formed under different conditions, different temperatures, different pressures. The kind of variations you'd only get from material streaming in from multiple star systems at once. The measurements from August confirm it. James Webb Space Telescope locked onto 3i Atlas with its near-spec instrument, the most advanced infrared detector humanity has ever built. What it found rewrote the textbook on interstellar visitors, carbon dioxide everywhere, dominating the spectrum, overwhelming the typical water signature that defines our comets. The kind of chemistry that shouldn't exist in a single object, but might appear in a mixed stream of debris from different origins. And that's not the strangest part. The wide field images from November 10th reveal an ion tail stretching tens of thousands of kilometers, a massive plume of charged particles streaming away from the object, visible across 0.7 degrees of sky from ground-based telescopes in Italy. But here's where the official story starts to fall apart. Just days before that massive tail appeared, observers in Spain captured 3i Atlas with no tail at all. November 8th, Naves Observatory. Crystal clear images showing a tailless object moving through space. 2 days later, a tail tens of thousands of kilometers long. That's not how comets work. That's not how physics works, unless something else is happening here. Kaku's stream theory explains this perfectly. If we're passing through a dense debris field, 3i Atlas isn't travelling alone. It's encountering pockets of material, clouds of dust, fragments from other objects. Each collision triggers new outbursts, new activity, new tail formation that appears and disappears based on what it hits. The radio signals detected on November 11th add another layer. Meerkat telescope in South Africa picked up emissions from hydroxyl radicals, the signature of water molecules breaking apart under solar radiation. Natural, expected, normal, except for the intensity. The signal strength suggests massive water loss at distances where water should be frozen solid, locked away, inactive. Unless external impacts are exposing fresh ice to space, Harvard astrophysicist Avi Loeb sees it differently. On November 8th, the same day those tailless images emerged, Loeb reignited speculation about artificial origin. He points to the missing tail, the unusual jets, the behaviour that doesn't match natural patterns. Where Kaku sees a debris stream, Loeb sees potential technology. But even Loeb admits the evidence isn't conclusive. Not yet. The upcoming observations will change that. December 19th, 2025. 3I Atlas makes its closest approach to Earth, still 1.8 AU away, further than Mars, but close enough for every major telescope on the planet to lock on. Hubble, James Webb. The combined power of ground observatories from Chile to Hawaii. These observations will map every detail, the shape, the rotation, the exact pattern of outgassing, whether the object shows structural integrity or signs of fragmentation, whether its acceleration matches pure physics or shows anomalies. Kaku emphasizes this date repeatedly in his analysis, because if his debris stream theory is correct, we should detect companion objects, smaller fragments travelling the same path. A whole population of interstellar visitors clustered together instead of randomly distributed. The implications stretch beyond one object. If Earth really is passing through a concentrated stream, our encounter rate will stay elevated. More objects will appear, each one carrying clues about conditions in other star systems, each one potentially different from anything in our solar system. The mainstream scientific community remains skeptical. Most comet specialists argue 3I, Atlas, behaves like a natural comet. Extreme, yes. Unusual, certainly, but still within the bounds of known physics. If you push the models hard enough, they point to similar behaviour in solar system comets. Comet 29P, Schwarzmann-Wachmann shows random outbursts. Comet 17P, Holmes brightened by a factor of 1 million in 2007. Extreme events happen, especially with objects we don't fully understand. But Kaku's math tells a different story. The probability of 3 interstellar objects appearing so quickly is less than 1% using standard models. Unless something has changed, unless we've entered a region of space with different rules. The timing supports this. Oumuamua in 2017, the first confirmed interstellar visitor. Then 2I, Borisov in 2019. Now 3I, Atlas in 2025. The gaps are shrinking. The detection rate is accelerating. That's not improved technology finding more objects. Our telescopes haven't gotten 3 times better in 7 years. The Atlas survey that found 3I. Atlas uses the same detection algorithms it did 5 years ago. The increase is real, physical, measurable. Kaku traces this pattern to orbital mechanics. Our solar system doesn't sit still. It orbits the galactic centre at 220 kilometers per second, fast enough to circle Earth in 3 minutes. As we move, we sweep through different regions of interstellar space. Some regions are empty, others are dense with debris from ancient stellar collisions, supernova remnants, planetary system formation zones, streams of material ejected from dying stars millions of years ago. Right now, according to Kaku's calculations, we're in one of those dense regions, a temporary phenomenon, maybe lasting decades, maybe centuries, but finite. A cosmic weather pattern that will pass as our solar system continues its journey around the galaxy. The evidence from 3I Atlas fits this model. High carbon dioxide means material from carbon-rich stars, the kind that form in different parts of the galaxy, mixed with water ice from other sources, a cocktail of materials that could only come from multiple origins. But that's where the controversy deepens. Fresh data from the Virtual Telescope project in Italy shows something unprecedented. The iron tail they captured doesn't point directly away from the Sunday, it shows a slight curve, a deviation that suggests additional forces at work. Solar wind can't explain it. Radiation pressure can't explain it. Standard comet physics breaks down when you try to model this behaviour, unless the object is interacting with something else, something invisible, something in the stream. Kaku's analysis includes a startling possibility: dark matter. If the interstellar stream contains dark matter clumps, and mathematical models suggest it should, then 3I Atlas might be our first detection of dark matter effects on a macro scale, not through gravitational lensing, not through galaxy rotation curves, but through direct physical interaction with a visible object. That would rewrite physics. The skeptics fire back immediately. Dark matter doesn't interact with normal matter that way. It passes through. It doesn't create ion tails or trigger outbursts. Unless we're wrong about dark matter, unless the stream contains something else, something we haven't theorized yet, something that only reveals itself when objects pass through at the right speed and angle. March 16th, 2026 offers another crucial test. 3I Atlas will pass within 0.36 AU of Jupiter, close enough for the giant planet's gravity to measurably affect its path. If Kaku's stream theory is correct, Jupiter might capture some of the smaller debris, creating a temporary cluster of interstellar material in Jupiter's orbit. The Juno spacecraft is already being repositioned. NASA quietly adjusted its orbital parameters last month, officially for routine observations. But the timing aligns perfectly with 3I, Atlas's approach. They're preparing to measure something they're not talking about publicly yet. ESA's Jupiter Icy Moons Explorer launches next year. Another coincidence? Or coordinated preparation for studying the stream Kaku predicts? The mission parameters include targets of opportunity, flexible observation windows, the kind you'd need to study unexpected visitors. Meanwhile, the ground-based observations continue to confuse. November 12th data from Chile shows the object brightening. November 13th data from South Africa shows it dimming. Not the gradual changes you'd expect from rotation, sharp jumps. Like something is happening to the object in real time. Kaku interprets this as collision events, small impacts from stream debris, each one exposing fresh material, triggering new outgassing, creating the appearance of random behaviour when it's actually predictable if you know about the stream. The mainstream explanation struggles here. Thermal fracturing could cause sudden brightening. Rotational changes might explain some variation, but the speed and frequency of these changes pushes those models to their breaking point. That's what makes December 19th so critical. Multi-wavelength observations will capture everything. Radio through gamma rays, every possible signature, every piece of evidence needed to determine if this is a natural comet or something else entirely. The space agencies are taking this seriously. Behind the scenes, telescope time is being cleared, observation schedules rearranged, resources that typically require years of advanced booking suddenly available for 3I Atlas studies. They know something, whether it's Kaku's debris stream or Loeb's artificial origin hypothesis or something completely different. The scientific establishment is mobilizing like never before for an interstellar object. The public statements remain cautious. Natural comet from another star system, they say. Interesting but not unprecedented, they claim. But the resource allocation tells a different story. You don't reschedule Hubble for a routine comet. Michio Kaku himself remains scientifically careful. In his November 3rd statement, he explicitly warned about misrepresentation. Deep fake videos claiming he said 3I, Atlas, was an alien spacecraft. He never said that. He's proposing something more subtle, more profound, a natural phenomenon that changes everything. If we're in a debris stream, it means interstellar space isn't empty. It's full of material. Streams and currents and eddies of debris flowing between the stars. A vast network of matter we've never mapped because we've never been able to detect it until now. The carbon dioxide measurements are the key. No single star system produces the ratios we're seeing. The chemistry requires mixing, multiple sources, different stellar environments contributing material to the same stream. Think about what that means for planetary formation. Every planet, including Earth, formed from a disk of material around its star. But if streams like this pass through during formation, they'd contribute foreign material, isotopes from other stars. chemistry from distant supernovae. We might be made of more than just our sun's leftovers. Part of Earth could be interstellar, delivered by streams like the one Kaku claims we're in right now. It would explain isotope anomalies in meteorites, chemical signatures that don't match solar system patterns. But here's where the data gets truly strange. The trajectory analysis shows 3I. Atlas isn't following a simple hyperbolic path. There are deviations, small ones, but measurable. The kind that suggest it's been influenced by something other than our sun's gravity before it got here. Kaku's calculations suggest multiple gravitational interactions, not just one star, several, as if the object has been bouncing through a network of stellar systems, carried along by the stream rather than travelling independently. That changes the whole picture. Instead of rare random visitors, we're seeing members of a vast interstellar highway, objects that travel together, share similar paths, follow currents we're only beginning to detect. The November radio observations support this. Meerkat didn't just detect hydroxyl from 3I, Atlas. There were additional signals, weaker ones, from regions near but not exactly at the object's position, as if there's a cloud of smaller fragments travelling alongside, too small to see optically, but large enough to produce radio emissions when solar radiation hits them. A ghostly companion cloud revealed only by the most sensitive radio telescopes on Earth. If confirmed, this would be the smoking gun, proof that 3I, Atlas, isn't alone, that it's part of something bigger. A stream of material dense enough to contain multiple detectable objects at the same time. The skeptics have explanations: instrumental artifacts, processing errors, interference from terrestrial sources. The same doubts raised about every major discovery until overwhelming evidence forces acceptance. But Kaku's math is solid. The statistical analysis uses the same methods that predicted gravitational waves. Located exoplanets, mapped dark matter. This isn't speculation, it's calculation based on observed data. 3 interstellar objects in 7 years, each one different, each one carrying unique chemistry, each one suggesting origins in different stellar environments, but all arriving during the same brief window of cosmic time. The odds of that happening randomly are astronomical, unless it's not random, unless Earth has entered something, a region of space fundamentally different from where we've been for the past million years. The geological record might hold clues. If streams like this are periodic, passing through every few million years, they'd leave traces. Isotope layers in ancient rocks, chemical anomalies in deep ocean sediments, patterns we've seen but couldn't explain until now. Kaku points to extinction events, not as proof, but as possibility. If a dense enough stream passed through, it would increase impact rates, deliver unusual chemistry to Earth's atmosphere, trigger climate changes through dust and debris. The dinosaurs died from an asteroid impact, but what if that asteroid was part of a stream? What if extinction events cluster because Earth periodically passes through debris-rich regions? It would explain patterns paleontologists have puzzled over for decades. The December observations will test these ideas. High-resolution spectroscopy will determine 3I Atlas's exact composition. Every molecule, every isotope, a chemical fingerprint that will either match Kaku's stream theory or falsify it completely. Radar observations will map its shape. Is it a single object or a loose collection of fragments? Does it show signs of recent collisions? Are there smaller objects travelling alongside? Each answer constrains the possibilities. The stakes couldn't be higher. If Kaku is right, we need to prepare. More objects are coming, each one a potential impact threat, each one requiring tracking, analysis, possible deflection. Our planetary defence systems aren't designed for streams. They're designed for single objects, random encounters. not sustained bombardment from a concentrated debris field. We'd need new strategies, new technologies, new international cooperation to handle multiple simultaneous threats. But there's opportunity here too. Every interstellar object is a free sample from another star system delivered to our doorstep. If we're in a stream, we have a limited window to collect these samples. Study them. Learn about stellar systems we won't visit for thousands of years. Some scientists are already proposing missions, fast interceptors, spacecraft designed to catch and study interstellar visitors. If streams are real and predictable, we could position assets in advance, be ready when the next object appears. The technology exists. We've landed on comets, returned samples from asteroids. An interstellar intercept is harder, but not impossible, especially if we know where to look, when to launch, what trajectory to follow. Kaku's stream theory provides that roadmap. But first, we need confirmation. December 19th looms large. Every major observatory is preparing. Space agencies are coordinating. The entire scientific community is watching. What they discover will determine our path forward. If 3I Atlas behaves like a normal comet showing predictable activity, standard chemistry, simple trajectory, then perhaps we're seeing statistical clustering. Unusual, but not impossible. The stream theory fails, but if it shows anomalies, if companion objects appear, if its chemistry defies single origin models, if its behaviour suggests external interactions, then Kaku's theory gains support and everything changes. We're not alone in space, not in the alien life sense, but in the physical sense. Space isn't empty. It's full of streams and currents, rivers of debris flowing between stars. And right now, Earth is sailing through one of them. The countdown to December 19th has begun. Telescope time is booked, instruments are calibrating, scientists are preparing for observations that could redefine our understanding of interstellar space. Whatever they find, one thing is certain. 3I. Atlas has already changed the conversation, forced us to consider possibilities we'd dismissed, made us question assumptions about how isolated our solar system really is. Michio Kaku's analysis, controversial as it seems, is based on real data. 3. Interstellar objects. 7 years. Impossible odds, unless the game has changed, unless we've entered something new, a cosmic stream that's been flowing for millions of years, waiting for us to discover it. The evidence continues to accumulate. The latest brightness measurements show variations on hourly timescales, not the smooth changes of rotation, not the gradual evolution of sublimation, sharp jumps that suggest ongoing events, impacts, collisions, interactions with unseen material. Each observation adds another piece to the puzzle, another data point that either supports or refutes the stream hypothesis. The picture is still forming, still uncertain, but increasingly compelling. The scientific method demands skepticism. Extraordinary claims require extraordinary evidence. Kaku knows this. He's not claiming certainty. He's presenting a hypothesis based on statistical analysis and observed anomalies, a hypothesis that will be tested. December 19th isn't just about one object. It's about understanding whether our cosmic neighbourhood is fundamentally different than we believed, whether streams of interstellar debris regularly pass through our solar system, whether we're in one right now. The implications for future astronomy are staggering. If streams exist, they're highways for studying distant stars, each object a messenger carrying information about its origin, chemistry, formation conditions, stellar environment. We could map the galaxy without leaving home, study stellar systems through their debris, build a chemical atlas of our cosmic neighbourhood, all by catching objects as they stream past Earth. But only if we know they're coming, only if Kaku's analysis proves correct, if the statistical anomaly is real, if 3 objects in 7 years represents a new normal, rather than a cosmic coincidence. Time will tell. The data will speak. December 19th approaches. The truth about 3I Atlas and about Kaku's interstellar stream theory will emerge from the combined observations of humanity's most powerful telescopes: natural comet or stream member, isolated visitor, or part of a cosmic highway. The answer matters, not just for science, but for understanding our place in a universe that might be far more connected than we ever imagined. The observations will determine which interpretation stands. Until then, the mystery deepens. The debate continues. And 3I Atlas races toward its appointment with history, carrying secrets we're only beginning to glimpse.